Okay. Okay, so I'm recording and quiz we had last week. Okay, so again, when we see percentiles, for example, I'm 54, so 54 students are above me, and 46 above me. So some below. So I'm on the 50. Okay, so I will draw for you here. Just a second. How I draw. Okay, it's a different program. Just a second. Oh, so when we talk about percentiles, for example, you know, I'm here, I'm 54th percentile. So it means 54% of all the grades are here, all the student grades, and 46 are here, right? So you can understand where you are, right? Where you are in the group, right? So I'm better than 54%, but worse than 46. So these are the questions related to that. Percent of student scores, okay? So again, it shows you your quality in relation to others. A percentile is the percentage of individuals in the data who are below where your in particular number is located. Yes, true. The standard deviation of data set, denoted by S, represents typical distance from any point in the data to the center. It's roughly average distance from the center, and the center is average. Okay, so again, look at this normal. Okay, here we have what is called normal distribution. You see, half of all the numbers are on one side, half of all the numbers are on the other side, right? So for example, this is the weight of students. Some students are very fat, some students are very skinny, most students are here, okay? Okay, and let's look at another example. And standard deviation, right? 1 point, 2 points, and this is the center, okay? The center of all the data. So but it's not always the case. Sometimes data is influenced by something. So let's look at these pictures. Okay, look, sometimes there's a skew. For example, I start giving chocolates to all the students. So students get fat, right? So all the data will move, right? So now it's not normal. So now there's more fat students. Or, for example, government decides to close all the shops. So students don't eat enough. Then there will be more skinny people, right? So this is the weight, right? The weight of students. I draw moment. I will draw. So so this is 0 kilogram, and this is 100 kilograms, right? And then normal distribution will be like this, right? Very few students are very fat, very students are very skinny, right? And this is percent. This is kilogram. So most students will be 50 kilograms. Example, right? High school, right? Not maybe university, a little heavier. And this is percent, right? Percent. Here, percent. But if I start giving cookies, then students will get fatter, right? So average will be 55, and then most students will get fat, right? But another scenario is something happens with and there's not enough food, right? So average will become 45, and most students will be skinny, right? Again, this is visual representation of data, right? We just collect ask what's your weight, what's your weight. I ask everyone, and then we put it uh, in this representation, so it's easy for eyes to understand, right? So normal distribution, normal conditions, right? If everything is normal, I don't give extra cookies, government doesn't close the shops, you can eat as enough, this is called bell curve. So in nature, everything is normal distribution. Your grades, right? Some students have 100%, but not everyone. Some students have, very low scores. Most everyone is in the middle. Okay. The median, right, of the data is the place that divides data in half. If when we put all the numbers from low to high, and the median will cut it in half. Average is also called mean. Categorical, category. How many boys, how many girls? 10% boys, 10% girls, okay? Categories. Ordinal. Ordinal data appears in categories, but the categories have a meaningful order, right? So we'll put all the girls in the age groups order. Numerical data. Each student will write about, their weight, their height, age. Average, very easy to find, right? We take, for example, we have numbers, these numbers, 22 plus 15 plus 17 plus 22 plus 31. Total 107. And how many we have? 1, 2, 3, 4, 5. Divide by 5. 21.4. Okay, average. So this is how they find average. So we can imagine the average, right? On the other hand, let's look at this. We can put these numbers on a line, right? So first goes 15, 17, 22, but it's 2 times, right? 31, right? So from 15 to 31. So the middle is we need to find the middle number. Okay, so it's between 15 and 31, so something like 21 here, middle. Okay, we divide. And same with average. Often average and median are the same. Okay, we can okay, we can divide numbers into quartiles. First quartile, second quartile, third quartile, right? All like this. First quartile is 25% of the data. Second quartile, it's here in the middle of the data. And then third quartile and the fourth is, okay. So we just divide all the data in quartile. Quartile means 4. Lower quartile, middle quartile, upper quartile. Quartile formula. You don't need that. You don't need. And also look here. Sometimes I get student results, right? Some will be very low score, very high score, and then most data is here with median, lower quartile, upper quartile. So let's go back. 25% is the first. Median is the 50th percentile. Q3 minus Q1 reflects distance taken by innermost 50% of the data, right? 50% of the data is between Q1 and Q3. 75th percentile is Q3, okay? So this is the quiz you had last time. Questions about anything? Okay, so today we study charts and graphs. Again, in statistics, we can do analysis, we can study data, right? We can do deep analysis, but often in everyday life, we just need to organize data in some charts and graphs, and then it's easy to understand things. Okay, like every day when you watch the news, they talk about COVID, and then they show some graphs, right? And then because most people cannot understand numbers, right? But when they show the graph going up, going down, then people think they understand, right? For example, they say 10 people died, but is it a lot or not, right? Right? So just a second. Just a moment, please. Just a second, I connect something to my computer. If I can, just a second. Okay, so now I have another device connected. Let's see how it works. Okay. Okay. So for example, if they tell you 10 people died today, they go on the news and they tell you 10 people died of COVID. Is it a lot or not? Anybody wants to say anything? 10 people dead. It's all over the news, right? But um, just a second. Uh, 10 people in where in if at the in the class, let's say in the class we have 40 people, right? So 10 people would be uh, a lot, right? 25%, that's a lot, right? If we have 40, if at the university we have several thousand, right? But in the country, let's say you have 70 million, or in China, 1.4 billion, right? This is not much, So uh, statistics can tell us, right? Percent of the population, percent of the population, percent sick, right? So maybe this is 1%, 2%, and this is 10%. So percent of the population will be here. And then we can compare with other things. So for example, uh, this is some flu, and then motorbike accidents, we can see higher. And then, so this is motorbike, and this is COVID, right? So we can compare two things, and then, oh, percent, this is percent, uh, percent of population of the country. Okay, now I can see with my eyes that, what is more dangerous, right? Because when they just give you numbers, numbers might scare you. But when you look at in relation to the country, in relation to other problems, right? Then it's less scary. Then you can understand what is more dangerous, right? Okay, so again, the main purpose of the data is to display, the data display is organize and display the data to make your point clearly, right? We communicate our data. You understand everything. You understand something is dangerous or not dangerous, but you need to convince people. If you will show them all the numbers, they will get confused. But if you show them graphs, charts, and people understand, and it's okay, understandable. Pie charts. What is a pie chart? Imagine a pizza, right? A round pizza. So this is 100%, the full pizza, everything is for you, right? But then if we cut it in half, this is 50%. Okay, we cut it in quarter, 25%. So this is how pie charts work, right? And so, and then we can divide. You see, Florida spend money on lottery, so 50% went to prizes, 38% goes on education. So when you buy a lottery in Florida, 50, for example, you pay $10. No, let's say you pay $1 for the lottery. When you buy a lottery, 50 cents, so half, you see, this is half of the circle, will go to prizes, so somebody will win the money. 38% goes to education and advertising, so this is everything divided. So pie chart is very, now I can see with my eyes, oh, look how much money goes to education. 38 cents out of each dollar. Oh, okay. Or we can say percent, right? Same with percent. But we need to make sure that it's all 100%. We need to put it all together and it needs to be one. Otherwise, I will show you what can happen. So, elections. Every country has elections. So she's standing in front of the screen with elections. And if you put it all together, it is 146%. So it's fake, right? So when you present data, all the numbers should be together 100, right? Because it's percent out of 100, right? So 146 is fake number. Somebody didn't study statistics. Okay, it's not the number in each group. It's just percent. We don't know, right? So for example, Rajapat University students, we can say 50% Thai, okay, Chinese, other, right? So let's say 25% Chinese example, 25% other countries. We don't know how many. We don't know how many is 25%. I don't know how many students. It's just percent. Bar graph. It's up to you what you want to use. You want to use pi or you want to use bar, anything to communicate with people. No difference. So we have groups. We can put it number of individuals or percentage. So pie chart, only percentage, but bar can be people, number of people, or percentage. We can compare different groups. side by side. So light number is 1975. You see 1975, 1975, 1975, and this is 98. We compare 2 years, right? So percentage of mothers who are working, right? Percentage of mothers, you see, this is 65%. This is 43 maybe, right? So we can see overall mothers with children. So in 1998, more mothers who have children are working, okay, than in comparison with 75. We also can look at different ages, okay? So this is different, right? This is they took two graphs and put into one. Okay. So again, this is called bar graph. This is a graph, right? Two graphs into one. So now let's say ages. Okay. Uh, age under 6, okay, 65%. But 6 to 17, 78. What it means is when children get older, in 98 mothers were working, and same thing about 75, right? And we can compare the numbers. 65 with 55, 30. So we can compare different years, right? So 39 will so we can look at each year. You see, when children are under 6, 65% of mothers are working. When children get older, 78% of mothers will work, right? So it's a increase from 65 to 78. Also, we can look at increase from 39 to 55. Okay, but look, uh, in 75, more mothers were sitting at home, so only 39 were working. And in 98, 65 are working. So it means mothers are working more. Okay, so economy is bad, or mothers want to work. So we can analyze this data, right? Now it's very helpful. You can look and understand. Okay, here percent, right? Percent, and here something like mothers with children. X, Y, right? Evenly spaced, right? 20%, 40%, 60%. It needs to be evenly spaced. Right? The scale, right? Uh, it goes up to 100. It depends how you want to do it. Okay? It would be interesting to know how many mothers, right? Because I can see percent, but how many mothers. So like, let's say 10 million total, so we can calculate exactly how many women. time charts, right? This is what they are showing us with the COVID. Okay, let's see. Okay, so 7 day. This is 7 day, last 7 days cases of COVID. Again, some people don't feel anything. It just they do the test and then, oh, you have COVID, or you don't have COVID. You have, you don't. So they last 7 days they put it here. Look, December there was nothing, and oh, sorry, it's not last 7 days. It's from June to January. So the highest number was in August. 7 day average. So they take 7 days and they do the average all the time. Okay, last 30 days. Let's look at last 30 days from December to January. Again, so you see, this is 0, 5,000, 10,000, 15,000. So this is called time chart. Again, here we have year, right? We can put year, day, anything, year. And this is something. It could be percent. It could be number of people sick. It could be some money. Average hourly wage for people. Look, how much money they get in 1 hour. It went to, the highest was in 73, and then went down and up, and then you see slowly is going down. So we see it over time. Okay. Population can change. Okay. So it gives maybe we have more workers now, right? So for example, we have more of something, right? And it can be misleading. So you have to pay attention. You see here, because in the country from 47 to 98, we have more people. Also, inflation. You know, in 1947, $7 was a lot of money, right? And now in 98, it's $12. But you think, oh, 12 is more than 7. No. In 1947, if you had $7, you could buy like a lot of things. But in 1998, $12 is much less. Okay? So think about Thailand. If you have 10 baht now, cannot buy, you can just buy a bottle of water. But think about 50 years ago, if you had 10 baht, you could eat a dinner, right? So this is important to understand when you show that. Okay, so when you work with the computer, you need to tell the computer where you want to put the years, where you want to put other things, okay? And if you change it, it could change perception. What units are we using, right? Dollars, anything. And we need to connect dots, right? If these are dots, we need to connect them. But what if we have one dot here and one here? Okay, 3 dots are hard to connect, so we need more data, and then it can connect nicely. Histograms. We show numerical data. Again, age of mother and how many mothers we have. Okay, so let's look again. We have a table. Mothers' ages. So histogram is a bar chart, bar graph that applies to numerical data. We order everything from largest, smallest to largest. Okay, so look, this looks like a normal distribution, right? So age of mother. Some mothers were 10, some mothers were 15. She is 15, she has a baby. Some mothers are 45. Most mothers, you see, with our eyes, we can see most mothers are around this age, right? This is when they have babies. Okay, percent. High, okay, 36% here. And look to year 2000. Now, if before, when mothers were 35, from 35 to 40, you see very few had kids. Now, from 35 to 40, more people have kids. But before, some between 15 and 20, 16% had kids. Now from 15 to 20, 11. So now it means women don't have kids when they're young, very young, and they have kids. More people have kids when they're older. Okay, so this is what this shows us, and then we can discuss why it happened. Okay. How data is distributed, right? We look. Is it symmetrical or skewed to the right, skewed to the left, bell shape, so on? How data is varied, right? Uh, is it from 10 to 50? Yes, 10 to 50. Where's the center, right? So center is here now. Center moved, so women get older and have a baby, right? So this is comparison from 1975 to 2000. Symmetrical, right? Symmetrical, bell shape, looks very nice. Skewed to the right, skewed to the left, right? So with babies, right? This is normal. They have babies when they are not old, not young, but here older, right? They will have babies when they're older, and here when they're younger. Okay, so this is very easy to understand versus this. Imagine if you have to analyze this. A little hard for, it takes time and most people will not be able to understand. What is that? Okay, variability of data. How variable the data is. Are they all together? Look, one data will be like this. So it means all women have babies, more or less at the same age. Whereas if you look at like that, it means uh, ages are different, right? How variable the data is. Very important to understand. So it's like nobody has a baby when they're very young and nobody has when they're very old. They all have it approximately around 25. Whereas here it's 18 to 50, right? Very stretched. And the data will be, again, maybe 25 is the middle, but still it's stretched. Like I told you, if you compare 75 to 2000, there's more variability in 2000. Changing times, more women are waiting to have children. In 1975, most women had children by age of 30. Okay? And now they don't. Histogram can also give you a rough idea where the center of the data lies. Okay? Center of the data. 1975, 25 was the center, and 27.5 year 2000. Women are having babies at older ages. Okay? Evaluate uh, okay. Blocks, interesting thing. Box plot. One-dimensional graph of numerical data based on the 5-number summary, which includes minimum value, 25th percentile, Q1, median, 75th percentile, and maximum value. This descriptive statistics divide data set in 4 equal parts. Okay, so let's look. So we take exam scores. So I have exam scores from 25 students. 43, 54, 56, 61, 62. Different students have different scores, right? Some scores repeat. For example, if we look with our eyes, we can see some numbers repeat. Maybe not, but look, lowest was here, 43, right? Very low. This is lowest. Highest was 99, right? So this is the summary. 43 is the lowest, 99 is the highest, right? And then this is uh, 68, 77, 89, right? So this is, and everything else is stuck here, right? So 43 very lowest, 99 highest, and then all the different numbers, but most numbers are stuck in this box. Okay, again for eyes. it is easy now to understand what is going on with this class, how they study. A box plot can show whether a data set is symmetrical or skewed, right? You see here, it's a little more data is in the higher portion, right? It's skewed, right? Skewed means moves. The upper part of the box is wider than the lower part. This means that the data between median 77 and Q3 are a little more spread out or variable than the data, right? There's more numbers there, so it's more spread. So 89 minus 77 is 12, and 77 minus 68 is 9, right? So more numbers are stuck here in the upper portion. This indicates the data in the middle, 50% of the data are set a bit skewed to the right, right? Skewed to the higher portion. Low exam scores are spread quite a bit more than the high ones. Okay, so this is a histogram of the scores. Right now we can see, oh, you see, more more people are stuck here in the 72%. So this is another representation, right, for the teacher. Okay, most people are around, a lot of people are number of students, right? Six. Around 6 students got 72, and same number got high scores, and just one student got very low. Okay, for the teacher, now he can understand whether students understand, and a few students are stuck here. The low exam scores are spread quite a bit more than the high ones, right? So the high ones are stuck. Here it means more people are understanding the material, more students. Okay. Variability in the data set that is described in the 5-number summary is measured by the interquartile range, IQR. How variable the data is. This indicates a fairly large spread within the innermost, large spread, right? So most students are here, but still there's a spread between them. There's a spread. They're not all together. There's a spread in the 50% of the data. IQR ignores data below 25th percentile or above 75th, which may contain outliers that could indicate the measure of variability in the data set, right? So we had some students who scored here, but for this method, it's not important. It just shows they're here, but how many of them are here, right? Interquartile range, Q3 minus Q1. This is how it works. The median 5-number summary shown by the line that cuts through the box. Okay. So this is your median, center of the data. Sometimes center is in the center, sometimes it's moving, right? It's easy to find. The median, the median, and the mean. The mean is not part. Mean is average. Median is the middle of the number, middle of the data, but mean is average. It's easy to misinterpret box plot by thinking the bigger the box, the more data. Okay, so be very careful with that. A bigger part of the box means more variability, wider range of values. It's all built around percentages, so be very careful when they show it to you. If you don't exactly, if you're not trained to understand box plot, you will be confused. They need to show you several graphs so you can understand what is going on, okay? Several graphs of several things. So for example, last 30 days, 7-day average COVID. Okay. New cases, okay. So look, this is 5,000 cases, 7,000. Okay, I'm moving. You see it's changing. Deaths. Okay, all the time, last 30 days. Now it's not 5,000, it's 20 people. Dead, 13 people. 19 people. 19 people, okay? Again, but another interesting thing is to how old are these people? Okay, they died with COVID, of COVID. How old were they? Were they sick? Right? We need to understand. Okay, vaccinations. Millions, right? So uh, with booster, fully vaccinated, first dose. Again, fully in Thailand, how many? 3 shots, 2 shots, I don't know. And booster is third or fourth percent of the population. At least one dose, 74% fully vaccinated, 68 booster, 18%. Tests, again, this is thousands. Last 30 days, 40,000. Okay, test taken per day, 66,000. Positive test, positive percent, 10%, 10%, 8%. So it's always around there. Okay, so this doesn't change because once a person has been vaccinated, they're vaccinated, right? So it could grow if we look at all the time, right? It's growing. This is when they started vaccinating, and then it grew, and then it's reached. So the person who has been vaccinated, he remains vaccinated, right? But now they need to, they want to see more boosters, for example, if people believe in that. Okay, so let's go back to the book. Okay, so this is this chapter: pie chart, bar chart, right? So there's several of them, and you decide which one you want to use. You decide uh, how to put the data, right? Because uh, we already have all the numbers. Now we need to show it in some uh, way that everyone can understand what is going on. Okay, so for example, let's look at this. Okay, so for example, we open the data, right? Again, it's not complete data. This is from an article. Uh, so they have all the numbers, and then they put it, and they make uh, I will show you how to make it. Okay, so we go to uh, just a second. Okay, we open Excel. Just a second. Before they had to do it by hand, it was very difficult. Now we have computers. Everything is very easy. You just need to know what you want, how it should look like. Okay? And what are you trying to tell people? Okay, so I will recreate. Okay, so I write motorcycle. Okay, so just a second. So let's compare. Okay, type of vehicle, motorcycle, accidents, 85%, right? So it's all percent. So 85. And then pickup 6.5, 85.2. Just a second. We need to pick up. Pick up 6.5, 0.5. So it needs to be all in percent. And then car 3.5. Just a normal car 3.5. And then other 4.8. Other 4.8. So sum 100%. Okay, so I have this data. For example, government gave me this. So now let's make it into a pie chart. Right? You see, I recreated the same thing. I can do something. I can play with the way it looks. Okay, just a second. I can do it 3D, more pie charts. Okay. Of course, you need to select the data. If you don't select the data, computer doesn't understand what you're trying to do. You can do it 3D. You can do it like this, any way you want. And then you can work what colors you want, what borders, text options. You can do arrows. You can do it like this. Okay, so this is what they had, right? Motorcycle 85. So now with our eyes, we can see that out of all the accidents, 85% are people on motorbikes, right? 6 pickup, car, other. So most of the accidents, and you have an accident, you are injured or dead, right? So most of the people who are injured or who are dead are on motorbikes, right? So this is what we see here. Estimated 70 to 85% of road traffic accidents in Thailand involve motorcycle. They are cheaper. Many young adults drive without receiving proper training. No license. Majority are young people between 15 and 29 years old. In Thailand, around 23,000 people die each year because of traffic accidents. 33% of all the people dead. So again, you look at Thailand, everyone dies, and 33% of people who die, they die because of traffic accidents. And inside of that, 85, right? So we can calculate. And then this is time, over time, right? So you look at over time from 2012 to 18. Songkran. What is happening on Songkran? 2016 increase. Road safety. road accidents on the map, right? They use different colors, so the brighter the spot, the more accidents there are. Of course, there's more people there, right? Okay, population density. More people live in Bangkok, so there will be more, largest 9 million people. But they're saying, however, there's little correlation between population density and road traffic accidents. Okay, so you see in Bangkok, there's more people, but maybe less traffic, right? Less traffic accidents. There's more cars, you have to be very careful. Whereas if you live in the Isan, maybe you're on the country road, there's nothing, you go very fast and then boom, dead. In Bangkok, maybe you cannot go fast. Maybe there's other cars around you, so you pay more attention. Bangkok, people have more money. So if you have more money, you will buy a car, right? But if you have less money, maybe you are on motorbike. So, conclusion. Road safety, major concern in Thailand. Safety on roads in mountainous regions such as those in northeastern Thailand also correlate greater instances of traffic. Thai government should take action. Use helmets, laws, speed limit, police, right? So like COVID, right? Uh, Suddenly we notice people are sick, people are dying. Oh, everyone must do something, right? But the traffic, people are also dying. We can see the numbers, right? If we, oh, look, 30%, 33% of all the people dead are dead in traffic. And mostly it's young, and mostly on motorbike, and mostly in the some rural areas. So let's save those lives. Let's put laws. If you don't have helmet, we arrest you, right? So same. Uh, Now in Thailand there's a law. If you do in Thailand there's a law, right? You need to wear a mask. But in England there's no more law like that you can do. So why Thailand doesn't have a helmet law? They have. So enforcement. So statistics helps us to understand the problem, right? We can see now with our eyes. We can explain to everyone that there's some situation, and we can change the uh, laws, maybe change what we do about it, right? Oh, I didn't know it was that much. Yes, it's that much. Oh, we need to do something about it, right? We now see it. Okay, so this is a very basic thing. Okay, just a second. Okay, we have 25 people in the group. Okay. Okay. So, do you have any questions about what you saw, what you heard? Any comments? Okay. So, again, in Excel, it's very easy these days to do graphs. You just select your data and then you do insert and then you choose sorry, insert, and then you see what's it's recommending, right? Bar, clustered bar chart, right? Sometimes it will give some nonsense stuff to you, so you need to decide, no, it doesn't work, okay? So this is again, you can see, oh, motorcycles are leading, okay? So this is an important thing. So just a second. So next week, you will do mini presentations, 2 minutes per person, okay? So you will find some article with some statistics, okay? But please don't all use COVID, right? Because otherwise it will be all the same, right? Find some statistics about how much money people borrow from banks, how many children they have, how many animals they have, how many apples they eat, how many cars they have, how much. Okay, so please do not use COVID because it will all be the same for everyone, or vaccine, find something else other than COVID. You can do health, you can do cancer, you can some accidents, how many people died of what problems, how many people had flu, how many people eat vitamins, okay? You can just read the news, uh, and you will see a lot of articles with numbers. So if you can create, I will give you extra points if you have, if you can do your own chart, uh, okay, your own graph, like we studied today. Okay, so I'll give you extra points if you create your own, but I want to see the article. So what you will do, just a second, you take Microsoft Word, for example, and you put the article text and then the where you found it, what website, and then if you create your own images, you put your images there, right? So look, I go to Microsoft Word, for example. Microsoft Word, just a second. So I start Microsoft Word, and we have 25 people, so no more than 2 minutes per person, okay? You will tell us what you found. Okay, so this is my document. I copy and then I put it here. Okay, and then for example, I go back to this text. I copy the text. The text is here, and then I cut the address. Okay, so we will know where you got it. So you will tell us something interesting that you found in the news, right? Please, no COVID. Anything else? Any country's website? Any information? Anything you think is interesting? You can copy text. You can copy pictures from the website. But if you create your own things, I will give you extra points, okay? If you create in Excel something by yourself, okay? Then you will get extra points. So and then you read that chapter that we covered today, and I will make a quiz today. So please ask me any questions. Okay, just a second.